Okay, so this is my NEA technical solution for my image classification and filing project. So um, here we just have a folder of random images with random names that the user would get onto their computer off their camera by transferring it. So then if we run the program, this is what you're prompted with first, which is just a little message. And then you have the GUI here. So then once you press start, the program will start loading in those images, and using the neural network training system, it will make a prediction of what it believes the image is. So you can see it's a coat, and that's what it said. So then if these match up, you just press this green button here, as these all right, and then these buttons below are used to manually adjust the assigned class for the current image if the system was to get it wrong. Let's say, so if this didn't come up with a sneaker, you would then press the sneaker button down here, and that would have the same effect. So yeah, it's just gonna go through all of these, work out what they are. As you can see, it's getting all of them right so far. Yeah, so it's quite quick. You can just press this button quite quickly, just churn through. So all of these are right. The accuracy is quite high for this data set. So then, yeah, you get to this point, it will say all images classified. So all those images in this folder have now gone. Okay, so then at this point you have buttons over here. So this performance button shows you the accuracy of the neural network from the training stage. So as you can see here, epoch 1000 against about 80% accuracy, which is quite good given the size of the data set. This train system button here, I'm not going to press it now because it takes quite a while to run, but it basically just reruns the neural network and tries to improve the current accuracy levels. If it achieves an accuracy level greater than the about 80% as seen on here, then it will override the settings and parameters for the network to improve the accuracy. Okay, so then down here you've got a create folder button, and then you can see here you've got the classes. So these are the different classes of images from that set. So you might just want to make a folder called shoes, let's say, and in here you might want to put all the different types of shoes. So you press that, and then that's going to move all those images with that have been renamed and organized. So if we just do up here, you might want to say something like this, I don't know. And then finally, I don't know, you might just want to go other, and you can get all the classes in here. So then all the images have now been moved. And then in the show folders, you can see summaries of everything you've made. File names for the folders, the class of images in there, the number of images, and obviously each image themselves in there. As you can see, they've all been assigned sort of meaningful identifiers. So now you can deduce which image is which. So yeah, just to show that's worked in here. So some of these are old. If I just do these today, so you can see the three from today. Other, so they are all out in here, and we also did tops and shoes. So these are the three we just made now. As you can see, all images are nicely sorted into their folders, and they're assigned proper names so you can see what they are without having to open the image. So yeah, just a quick talk through the code. This is the GUI page, which is all the display, all the buttons, and it kind of links up all the features up here from the other files together. So that's just kind of piecing everything together. The image renaming, this file kind of basically takes a look at the images already in the folder, sorts them using a merge sort, and it works out the next identifier. So let's say you had images 1 to 6 of a coat in the file. This We then work out that the next one needs to be called coat 7, if that makes sense. Yeah, so this is the neural network page, which basically is training off images like these from the fashion data set. There's about 60,000 images. These are t-shirts, coats, whatever. So this is what it trains on, all these images. They look like this. So they are passed in. The network's trained. Yeah, gets good accuracy, and then the weights and biases are stored to external files so that you don't have to train it every time you open the program. So they are all stored in here in CSV files. So just an example, you can see, so these are the biases for the layer 2 of the network, and these are opened and read when needed. So then, yeah, you've got the training one, the testing one, which is then used to pass in the images from this file here that we looked at earlier. These are the sort of pixel values for those training images, which are then accessed and converted into inputs for the training neural network. And then finally, we have the filing system, which again is used to set up the folders, move the images, look after all the folder properties, and then obviously display them like we saw in the program. But yeah, that's pretty much it. Thank you for listening.